Hello everyone. In this video, we are just going to see about serial communication programming in 8051 microcontroller using Keil. So we will go stage by stage by we can able to transmit a signal, we can able to receive a signal, and we can able to have different modes in communications. All those things we can able to see it one by one in different experiments. So in basic, serial communication says that we are going to use only single line communication, and we will be having a transmitter and we are having an transmitter and receiver. So you will be using a single wire for its communication, and if it is going to be parallel communication, as like in 8051, we are having communication with respect to ports, right? So we are going to interface with keypad and other things. So we are having different lines for communication of data. So if it is going to be 8-bit, we are going to have lines from 0 to 7. So here we can able to send the data in a parallel way. We can able to start it from data D0 to D7. All the bits can be sent in a particular instant of time. But here we are going to send the data one by one. So first we are going to send the data of D0, and after next instant of time we are going to send the data of D1. Like that we have to send the instant of data up to D7. Or if you are going to send a data of particular hexadecimal values also, we are going to use the same method. So the transmission is serial, it's not parallel communication. So we are going to send bit by bit from transmitter to receiver. So here it is going to be the transmitter and here it is going to be the receiver, right? So if you are going to getting inside, so the question which is given to you, so write an assembly language program for 8051 to transmit character A. So using serial communication in mode 0. So we will understand what is mode 0 when you are going to get inside the theoretical aspects of mode 0. So what is the data which is given to us? So we are going to transmit the message A, and after that we have to operate in mode 0. These two are the informations which is given to us. So with the help of these two things, we can able to go and understand what is mode 0 and how to transmit the data. So first we have to understand bits per second. So I have already said that we are going to send bit by bit. So we are going to calculate the speed with bits per second, right? So the widely used terminology is going to be baud rate. So in modem terminology, it is going to be defined as number of signal changes per second. But as far as your conducting wire is going to be concerned, baud rate and bits per second are same. So how many bits it can able to do in terms of operation with respect to second. So that is what we are going to see here. So in terms of communication, we are having synchronous, we are having asynchronous communication, and what are the registers which is being involved. So SCON register. So we will try to understand what is SCON register and how to make use of this SCON register also. And in terms of data transfer, we are having transmission pin and as well as receiving pins. Same time, it's going to be like sometimes the clock is through transmission pin and sometimes it is going to be the receiving pin. So we have said like we are having different modes, right? So what are those different modes which is going to be understandable in terms of different modes? Mode 0 is going to be a synchronous serial communication, and mode 1 is going to be your 8-bit UART with timer data rate. So this is what the important terminology. So we are going to send 8-bit data with help of timer. So if you are going to operate with mode 0, there is no need of timer. If you are going to operate with mode 1, we need timer. We have already studied many things with respect to timers, right? So we are going to use the concept of timers in your mode 1, and mode 2 is going to be 9-bit data, which is going to be with set data rate. And in terms of your mode 3 is going to be again with respect to 9 UART protocol with timer data rate. Again, it is going to be your timer which is going to be get involved. So we will try to understand what are the things which is going to be in terms of different modes while you are going to that specific experiment. So in general, what are the things in terms of registers which is being used? SBUF register, which is going to be your buffer data. So if it is going to be transmission, so transmitting data, we have to put it inside your SBUF, and we will be keeping it as a temporary buffer. And after that, we can able to send the data. So if you are going to move the data, which is going to be respectively with, okay, we can able to understand some 8-bit data is going to be transmitted. So 8-bit data, we are going to have 8 different bits. All the 8 different bits, we are going to send it to this SBUF, and one by one, we are going to send the data to the other end. So if I am going to receive the signal, again, if I am going to get the signal from outside world or outside equipment, so again, it is going to be an information storage. It is going to store the data from D0 to D7 one by one, and after that, it is going to send to the processor. So like this, SBUF is going to be a buffer register which can able to hold the information of 8-bit. Even it can able to transmit or receive. I am going to store it inside my SBUF register. SCON register is used to control your serial communication, and PCON register is used to control your baud rate of your transmission. So in experiment number 1, SCON is more than sufficient, which means your TCON register, if it is not initialized, which means like it is going to have the data of 0, 0. So we will understand why it is 0, 0 and what it implies while you are going to the forthcoming experiment. But as of now, we will be using SBUF register and SCON register. So SBUF is an 8-bit register. We are having transmission and receiving pins, and it is going to have start bits and end bits. So if you are going to take a data, it is going to have a start bit and it is going to have an end bit. So SBUF is going to hold the data when it is received from your 8051 RxD line also. And in terms of your getting data also, we are going to use that your SBUF, and we are going to hold the data for some duration of time. Right. So in terms how we can able to make use of your SBUF. So if I want to move the character value of D, so I can able to use immediate addressing mode, and I can able to store the value of D inside your SBUF. Actually, I am not going to save the value of D. It is your ASCII value of D. So we can able to hold the ASCII value of D. Whatever value of D is going to be there, that is going to be saved inside my SBUF register. So I can able to use it with register informations also. So I can able to move the information from accumulator to SBUF register to accumulator. All those things are possible with respect to SBUF register. So this is for general understanding. So what this SCON register implies? SBUF is a buffer. SCON is going to control. So how it is going to control? What are the things which is being used? We can able to see it one by one. So in terms of SCON, I am having 8 bits. So it is going to be 0 and it is going to be 7. So in between it is going to have different values. So all those things implies a specific thing which can be done, right? So here if you are going to take in terms of your SM0 and SM1, which means it is in serial mode 0 determination, mode 0 and mode 1. So here we can able to get in terms of combinations, we can able to have 4 different combinations from 0 to 0 to 1 1, right? So all those things means like it is going to be operated in different modes. So if it is going to be having the mode of 0 0, it is going to be used as an 8-bit shift register mode. And if it is going to be 1, 8-bit UART. If it is going to be 2, 9-bit UART. If it is going to be 3, again it is going to be 9-bit UART. So SM2, what it implies, it is going to be your multiprocessor communication. In this experiment, we are not going to use it. So in the question, we have been instructed like we have to use mode 0. If we want to use your mode 0, both the things has to be having the value of 0 and 0. So it can able to be operated in mode 0. So this also should be 0. So we are not communicating with multiprocessors. And if it is going to be what is with REN, to set to enable serial data reception. So if I am going to receive the data, I have to make it to 1. If I am going to transmit the data, I should not be enabling it to 1. So in the question I have given like you have to transmit the data, right? So this value should be 0 here. And after that we are having TB8 and RB8, which is going to be your 9th bit representation of your transmission and receiving if you are going to use your mode 2 and mode 3, extra 9th bit is there, right? It is going to represent those bits if it is going to be transmission and receiving, right? So when we are going to move to that mode, we can able to understand more about this one. But as of now, it is going to be mode 0. So we don't want these two bits also. So this also should be 0. So what is this in terms of TI? So TB8. So it is going to be 9th bit in terms of your mode 2 and 3. If it is going to be 9th bit of your receiving mode. TI. So it is going to be your interrupt set when your stop bit is transmitted. So like it is going to say that the transmission is completed, and RI is going to say your receiving is completed. So this is going to be your controller. So if I'm going to transmit, I have to give more concentration to TI. If I'm going to receive, I have to give my concentration to RI. With this TI and RI, I can able to understand whether the operation is completed or not. So this is used to understand which mode it should work, and this is to understand whether it is going to be multiprocessor or not. If it is, this is going to understand whether it is going to be transmitting or receiving. These two are the extra bits of your mode 2 and 3 for transmission and receiving. And TI, it is going to represent your transmission is completed. RI is going to represent your receiving is completed. So we have given an thing like it should be mode 0. So we have to understand what is mode 0, right? So mode 0, we have already said that it is 8-bit. It is going to be synchronous communication, right? So we can able to say in terms of mode 0, serial port mode 0 is as follows. Serial data enters and exits through RxT pin, and after that transmission outputs clock. So 8 bits are transmitted or received. So the baud rate is fixed at 1 divided by 12. We can't able to change your baud rate. So it is already fixed. If your oscillator frequency of this much, it is going to be 1 divided by 12 of that oscillator frequency is the baud rate. So we can't able to change the baud rate in your mode 0. That is synchronous communication, right? So these are the things with respect to mode 0. So we have understood what is mode 0, and we have understood what is SCON register, and we have understood what is SBUF register, and we can able to understand about serial communication and how it can able to be done till now, right? So how to make your mode 0? So this is your SCON register, right? So if it is going to be your SCON register, so how to get your mode 0? So D0 to D7. So these are the things which is respect to pins, right? So if it is going to be mode 0, it should be 0, 0. So this is your mode 0. So it is not multiprocessor communication, so it should be 0. So it is not receiving, we are going to transmit data, so again it is going to be 0. So we are not using your mode 2 or 3, so this is not useful for us in this experiment. So this also should be having the value of 0. So initially it is going to get the value of 0 and 0, because when it reaches 1, it is going to say that the transmission or receiving is complete. So what is the value in terms of all over? We can able to say it is going to be 0, 0H, right? So, or if you are going to say in terms of binary, so 0, 0, 0, 0. So again 0, 0, 0 B. So I can able to give it in this fashion also. So SCON register should hold the value of this 00H or 00000000B. So this is with respect to SCON register. So what is the solution? So I have said that it should be having the value of your A, right? It should be giving the information of A. So if it should be giving the information of A, so SCON should be, we have already determined what is SCON register, right? So it should be having the value of 00H. And after that, SBUF, so it is a buffer, right? So it is going to have the value. So I can able to transmit the character value directly. So this is going to be double quotation. So it can able to be transmitting the character value using this, or I can able to send the ASCII value of A, alphabet A, 61. So you can try with different alphabet values and ASCII values also. So you can able to load your SBUF register with 61 or A. So after that, when we can able to understand the transmission is completed, so we have already said, like in SCON register, TI flag should be reaching 1, right? So TI flag, when it reaches 1, we can able to say that your transmission is completed. So here you can't able to change the baud rate, right? So how we can able to check? So we can able to check, we are already having an familiar instruction, jump no byte, which means like it is going to check whether it is going to be having the value of 1 or 0, right? So if it is going to be set, it is going to be coming out of the loop. If it is going to be not set, it is not going to come out of the loop. Right? So if you want to check the condition, so jump no byte. So we have already seen. So what is the value we are going to check? We are going to check the register or the bit of TI. So after that, you can able to give the any address value. So I am giving an address value again. So what is trying to convey? So I can able to put again here. Why? Because so it is going to jump again and again inside this loop itself till it is identifying Ti is equal to 1. So when it identifies Ti is equal to 1, it is going to jump out of the loop. So why we should check Ti? Because we have to confirm that the alphabet A is being transmitted using serial communication. So the serial communication completes when you are going to see that when you are going to have your TI bit to be 1. Right? So after this is getting completed, you can able to clear your TI register so that it can able to move to the next step. So it is going to again we can able to move to this one. So if I want to display the value of A again and again and again, so it is going to be a never-ending loop. If I want to make like that, I have to jump again to that so that the SBUF is going to again have the value of A, and it is going to repeat the loop again and again. Right? So this is a program for transmission of data. So here we can able to see all the informations which I have given. So origin is going to be 0000. So I don't want to disturb any of my interrupt location. So I am using L jump here. So it can able to jump here, right? I am doing is because I don't want to disturb any of my interrupt locations, right? So if you want to start it at 0000 also, it's fine. You can able to do that. But make sure that you are not disturbing any of your interrupt memory locations. We have already seen what are the interrupt memory locations, right? So don't disturb those memory locations. So if I'm going to get it in terms like move the value of your accumulator with immediate addressing mode with the ASCII value of A, or I can able to move with the value of 61H also, right? So I can able to use anything. So if I know the ASCII values, I can able to use the ASCII values, else I can able to use the character values inside your quotation. So A called transfer. So it is going to determine the transmission is getting completed, right? So if I want to transfer the information, so it is a subroutine so that it is going to push that information inside your stack. We have already seen what is A called, right? So this is going to jump to an interrupt service routine. So the value of this one is going to be moved inside your stack, right? So this is going to be the memory location of this instruction is going to be moved inside your stack, and after that you are going to transfer, you are going to jump to this transfer. So it is going to be acting as an interrupt service routine. So it is going to be your interrupt service routine is going to start from here, transfer, right? So I am pushing the value of SCON with 00H or 000000B. Both the things are going to be same. It is going to say that what are the things it is going to convey? It is going to be operated in mode 0, and we are going to transmit a data. So these two things it is going to convey, right? These two bits is going to say that we are going to operate at mode 0, and after that fifth byte, right? So it is going to be in terms of this one is going to determine whether it is going to be your transmission or receiving. So if it is going to be 1, it is receiving of information. Here I am transmitting the value of A to your serial port or UART port. So after that, move your value of accumulator to your SBUF. So already the value of accumulator, we have already pushed the value of ASCII value of A inside your accumulator, right? So this SBUF is going to get your value of your ASCII value of A. So here we have to wait till the transmission is getting completed, right? So we have already seen using an again statement, right? That is going to be here. So I have used delay statement here. So delay sjump ti. So it is going to be determining, or it is going to be checking when your ti bit is going to be 1. Till it is becoming 1, it will not come out of the loop. It is going to be iterate again and again inside this loop itself. So when the transmission of A is completed, so your TI register can be, or TI bit can be cleared, and after that interrupt service routine is going to give and return. So return is going to be moving here, so that it is going to again say sjump here, right? So sjump here is going to be jumping back again here, so that the next value, so you have to print A again and again, right? So in that case, so this is going to be repeated again and again, so that it can able to print the value of A inside your serial port, or using your serial communication protocol. You can able to display the value of A, and you can able to see the output value of A, character A. So you can able to use your ASCII values, as well as you can able to use your uh, alphabet value using your quotation. So we can able to move inside your program. So yeah. So we can able to see the program here. So I can able to enlarge for clear visibility. Sorry. So I think zoom option. Okay. Okay. So we can able to visualize it. So this is a program which we are going to say. So transmit a data. Transmit a data. A transmit a character using serial communication protocol in mode 0, right? So I have given the same program here. So we can able to see your serial output using your serial monitor. We can able to see those things also. So in as like in peripherals, we are going to see in terms of your ports. Like the same way, we can able to see your windows with respect to serial port also. So go save this program, build, rebuild, into debug mode. So after getting into debug mode, so you can able to get to view. So it is going to be having serial window. In serial window, you can able to have your UART1. So serial communication, which you can able to get it in terms of view, and you can able to give into serial windows in that UART1. So this is going to be your serial monitor. So whenever I am going to send an information of A from this program, it is going to transmit the data to your UART monitor, which we can able to see here. So we can able to see your output here. So I have written a program to again and again display the value of A, alphabet A. It is small a, right? So if you are going to use your capital A, your alphabet ASCII value should be correspondingly saved inside it. So I can able to get the values one by one also, and I can able to see how far it is going to do the program. So we can able to jump, so that your SP is going to get the value of 0.7. So after that, I am jumping again. So see here, the value of A, I am going to get it here. ASCII values, I have got it here. So after that, it is going to confirm, right? So you are going to say your SCON register is going to getting the value of 0000. So all these things has been configured. So if you want to check it has been properly configured or not, so I can able to get inside your peripherals. In that peripheral, I can able to click on my serial. So in that serial, whether it is going to be configured in the perfect way or not, we can able to check that also, right? So after clicking on it, so it is going to say that it is an 8-bit shift register. So that is the thing which is respect to mode 0. So your SCON is going to hit the value of 00. So this REN is not enabled, right? So if it is not enabled, it is going to say that it is a transmission which is going to happen, right? So when the transmission is completed, so your TI will be enabled, right? That is what it means. So I can able to jump to the next location. So it is going to be a delay which is going to be used, so that the transmission is going to be completed. So SBUF is going to get the value of 61 here. You can able to see the value of 61 here, right? So the value of accumulator an ASCII value of A is going to be getting here. So after that one, I can able to jump again. So delay, so it is going to be jumping inside the loop again and again till the serial communication is completed. So you can able to see. So after 3 or 4 iterations, your delay is completed. So the serial communication is completing its transmission. So now you can able to see in your UART screen, you can able to see the value of A, right? So here you can able to see your TI is getting enabled, which means your transmission is completed. So if you want to move again and again, so it can able to return to the main statement of a jump here, so that it is going to move again to jump. So all these iterations is going to complete, so that it can able to have different values of A again and again. So if I'm going to completely run it, so I can able to see an infinite number of A's inside my UART screen, right? So this is with respect to your serial communication. So if you want to stop it, you can able to stop it and come out of debug mode. So like this, I can able to move character by character inside using your serial communication protocol, and you can able to send those informations, transmit those informations with different modes of communication in serial communication. So this experiment is with mode 0 and sending a single character or transmitting a single character A to your 8051, right? So in next experiment, we can able to see how to receive a data. Thank you for your patient listening.